Hello dear viewers, I'm pleased that I am able to show you some new topics and products of the WAGO world in this new format, the WAGO Webcast. In this webcast we will present you the electronic circuit breaker and the advantages over miniature circuit breakers and the communication of our electronic circuit breakers. In the webcast you can live question and we can answer them directly. If you are not able to take place in the live chat, so please feel free to ask our support. You will find the addresses in on our website. So to me, my name is Florian Kote and I'm the Business Development Manager for WAGO, the Division Electronic Interfaces. With this position, I support the sales department with special interface inquiries for customer requests. So let's get started. Also, in actual production machines, they use in the 24 voltage system miniature circuit breaker for the overcurrent protection. But with the characteristic, the magnetical characteristic and the thermal tripping characteristic, the miniature circuit breaker has a problem that we need a high overcurrent. So this means that in case of a shortcut, we need a high overcurrent. This is by a shortcut directly in the near of the miniature circuit breaker, no problem. But in case of we have a great distance between the circuit breaker and the shortcut, there is a high resistor in the wire, in the connections and in the circuit breaker. So then we have the problem that the overcurrent might not be so high that the miniature circuit breaker triggers. So for that, we have an electronic circuit breaker which can trigger by a specific characteristic on the overcurrent. So maybe you have just an overcurrent from the second nominal current. The electronic circuit breaker will trigger as fast as possible. If we have such a case with a long distance between shortcut and the miniature circuit breaker, the electronic circuit breaker is a better solution. So with the electronic circuit breaker, we have a specific characteristic which says that if you have maybe the second nominal current, that after a specific time the circuit breaker triggers. And this time is even shorter than the miniature circuit breaker would trigger. Here we have our pult, we have an I/O system, we have electronic circuit breakers and two different kinds of power supplies. On this little pult we have our shortcuts. We have a direct shortcut, we have a shortcut after around 20 meters, and we have a resistor. This resistor we need after that for the visualization on our WebViso. So first of all, I want you to show our shortcuts. So we have right now the direct shortcut directly behind the circuit breaker. So if we make a shortcut, we see that the electronic circuit breaker triggers. So and now here's the reset time. We have to wait, and after that we can reset the electronic circuit breaker. Now we will choose the 20 meters wire. So right now we have a shortcut after 20 meters. This is with the high resistance on the wire. If we now produce a shortcut, we have more than double of the nominal current our miniature circuit breaker can. So it has a great time lapse for his trigger. And last of all, I will show you the resistance. This is the greatest resistor we have, and therefore we have round about 1.9 amp. So we saw right now what happens, how much current we have on which shortcut. So we want to start right now with the miniature circuit breaker and start with the shortcut. So we choose the direct shortcut, choose the miniature circuit breaker, and if I trigger the shortcut, the miniature circuit breaker triggers directly. So if we now choose the 20-meter wires and we reset our miniature circuit breaker and we make a shortcut, it takes a long time for the triggering because we have a miniature circuit breaker with 2 amp and we have right now around about 4.6 to 4.7 amp overcurrent, and with the characteristic of these miniature circuit breaker we need round about the 3 to 6 times overcurrent. This means 6 to 12 amp and we just have 4.6 amp, so it takes a long time for the triggering. So let's have a look what happens in the next minute. So we see we have no trigger on the miniature circuit breaker. It depends on a longer time than also will trigger. But what we can now feel is that the cable gets really warm. So unless this is a bad case for your production machine, because then you can have a cable fire or the cable would burn. So if we switch now to the electronic circuit breaker with our link, so we choose the direct shortcut, we make a direct shortcut, and what we see is that the channel number 1 triggers directly. The channel number 1 is also right now on 2 amp. After a short refresh time it flashes orange, so we can reset it and set it on. And now we switch to the 20-meter wire shortcut. So we have right now 4.6 to 4.7 amp overcurrent if we trigger the shortcut, and this means that after a short or definite time the first channel triggers. We saw that green light was flashing, so he gave us a signalization that the first channel has an overcurrent, and then he triggers. With our WAGO electronic circuit breaker portfolio, you have many options of communication. On our one-channel ECB, you have the option of a digital input and a digital output. Over the digital output, you get status informations like if it's set on, set off, or if it's triggered. On the digital input, you can reset the ECB, you can set it on, and you can set it off. With our multi-channel ECBs, you have 2 options of communication. The first option is the Manchester code. This is an input sequence which was sent to our I/O system, and on the I/O system send it to our ECB. So you can do a configuration on the electronic circuit breaker, and you can get out every value you want, maybe the actual current. But this is a mostly slowly system. If you want a real time or is a fast system, then we have the I/O link option. With the I/O link, you have the options like configuration on the ECB, and you can get out every value. You also can set every channel, the actual current, the tripping current, and you can set it on and off. So right now I want you to show the communications. So we choose the electronic circuit breaker and we start with our one-channel ECB with the digital input and output. So, and right here we see we get the status, what it's happened right now. So it's right now off. So, and then we have the possibility to activate it. We have to write the configuration and then it's activated. Let's get back. So we choose the next electronic circuit breaker. Now the Manchester code. we would choose the 8-channel ECB. And here we have right now more informations, the actual current, and we have the possibility of configuration. So we can activate or deactivate the channels. Right now the third channel is deactivated. And now we will activate it, so I have to choose it and write the configuration. And now we have the impulse sequence, which was sent to our I/O system. And after the I/O system gets the information of the status, it will send the configuration we have done right now and send it to the electronic circuit breaker. This may take a little bit of time, but we will see right now. So right now you see the electronic circuit breaker channel 3 is activated. This is a little time delay we have, but we can use this. Maybe you don't need real-time traffic, you just want to have the status of every channel, and you want to have an information about your current, which is currently on every channel, but not every second, maybe just all 20 seconds. So the Manchester code is for you. You also need just a digital input and digital output card for your I/O system. If we go to the I/O link channel on the electronic circuit breakers, you see we have some more options. We have the status, we have the actual current, we have the current which is typed in by the channel, and we can switch it on and off and get also a status. And we can also write another current on which nominal current it should trigger. So right now we choose the 6 amp, so if we have an overcurrent over 6 amp, this channel would trigger. To the end of the webcast, I will show you the portfolio. This is the 1-channel ECB in the 6mm housing with the digital input and digital output for communication. And this are our 2 multi-channel electronic circuit breakers. As 2 or 4-channel electronic circuit breakers, you have this housing, that was the smaller housing, and for our 8-channel electronic circuit breaker you have the greater housing. On this you see we have the communication, the channel outputs, and the current and voltage input. I hope I could show you some new and for you relevant information for the electronic circuit breakers. Now you see me the speaker function to get with me in a discussion. For further questions, get to our website, ask our support, or find your local sales department. I thank you for your attention.